This is an example on function modeling. We are going to go through all the stages of function modeling. We're also going to exercise trimming, and we are going to apply both of these tools on a practical case. We are going to show how it was used to circumvent patents. Okay, first is the story. One company that dealt mostly with tobacco products decided to go a kind of healthy way to develop a product under the concept so-called heat-no-burn device. So definitely when you just heat tobacco, when you don't burn tobacco, it generates less tar, and but nicotine is still atomized, and definitely staying in touch with tobacco cut, you still reduce the harm. And that was an idea of the product. A marketing group worked on the concept of like premium class individual product, where tobacco comes in cartridges in a way like it is used in coffee machines with capsules. And the idea was to have a device that you install cartridge in, you push bottom, you wait like 30 seconds and enjoy the first puff. And in the slide you also can see like an inhaler prototype. A company uses it for medical or pharmaceutical properties, definitely to extract some medicine from herbs. So from the very beginning, it looked like a standard engineering project that well, any graduate of electrical engineering department could do, or mechanical engineering department. And we came up with an idea of like an obscure device, as you see, like this, with a cartridge inside. So we had to evaluate the amount of energy we need to extract certain amount of nicotine from the tobacco cut, how much it has to be heated, how heat is distributed. So we did some fine element analysis. We analyzed what kind of accumulators we are going to use or energy source. And then we came up with a layout of like a device. And well, as you see, and we were supposed to use a resistive heating. As you see here, like there is a winding. It is winded around the tobacco cartridge, and being heated, being connected to electricity, it emits heat. Okay, like this. Okay, but when we were almost ready with the concept, when we are going to deliver this concept to the customers realized that, well, we are going to intrude, we are going to face a patent of competitors. There were at least two companies. One was Reynolds Tobacco, another was Philip Morris, that, as you see in the patent, develops a device like this and this, where the same principle is used. So a resistive heating was used to heat tobacco in order to extract the nicotine. So there were at least two patents of direct competitors, and of course no cross-licensing, no negotiations were supposed to happen. And on the top of everything, we also found a number of patents where the similar idea could be found. So the lawyers said, no, we have to do about something different. So the task was to circumvent patents of our competitors. And the drama was that we had to do it really fast. So let us go through the function modeling exercise, because in function modeling, we analyze how system works, we define the functions, and we try to then to apply trimming in order to eliminate one or two or several elements, because when we trim, definitely we circumvent patents. Okay, first of all, we had to define, according to the rules of functional modeling, the list of elements that are players in the scheme. So let us not to go deeper into detail and focus mostly on the electrical circuitry, about on heating elements. And if so, we have to agree. We may agree that there are like 9 basic players, 8 players: tobacco, aerosol, heater, wiring, then electrical current, power source, control, and user. And there are like some elements are gray out. That means they're a super system, and the super system is an element we don't actually have control over. And as you see, all of those elements are either material objects or fields. So they are legitimate elements to be candidates to become a part of function model. So the next step, as we remember, is building an interconnection matrix, and we put the candidates in the matrix in rows and columns, and then we gray out the diagonal element, because of course each element talks to each other, to itself, and then we put pluses where we see interconnection. So definitely tobacco emits aerosols that they are in contact. They interact. Tobacco is in contact with heater because they really touch each other. Current is definitely conducted through wiring, so they're in contact, they interconnect, and so on and so on. So all those elements, or all those interconnections where we have pluses here, they talk to each other. Okay. So the next step would be to define, having assumed that elements interconnect, do they change parameters of each other? So, and then the final step would be functional model. So, omitting certain analysis step, we are coming up with a graphical representation of functional model. You see all those elements, and they're all linked by a flow of functions. And the function, as you remember, is legitimate when you can identify a parameter that has been changed or maintained as a result of this function. So all those functions are like generate, heat, direct, control, and even like a little bit romantic function that is called to please. So aerosol pleases customers, but we all know, of course, that nicotine kills. Okay, so before we go to the trimming exercise, we have again to revisit the value of trimming for pattern circumventing. If we have a patent we need to circumvent, we can build a functional model and then eliminate one or several elements. And then what we arrive at is another system. So let us try to experiment. If we just decided to remove heater, definitely, of course, the system is going to be different. And we can apply trimming rules, A, B, or C, in order to substitute the function, or to make the function, unnecessary in a way. So if we decided to go with rule C, if we find a candidate to do the function, and as you remember, in the rule C, we have to find another element, and the good candidate is the element that does the same function. So electric current would be a very nice candidate to heat tobacco. We can try to think about another system where electric current directly heats tobacco. And if it were possible, then definitely we could circumvent the patent where we have a heater, because there is no heater in such a system. And then a little problem appears how to make it possible, because something has definitely heat tobacco. So what if we think, also having in mind ideal final result concept, what if tobacco heats itself? Can we try to think like this? And the answer is, in theory, yes. Because if you pass tobacco through tobacco cut, beautiful things could happen. Fortunately, tobacco cut is wet, so it's not completely dry mixture of leaves. Fortunately, it has some syrup inside that is kind of salty. So altogether means that it could be electrically conductive. So if you pass electric current directly through tobacco cut, it's going to heat itself. Again, heating itself. That is sounds very close to ideal final result concept. There was the idea was kind of inventive, but realistic analysis tells that unfortunately there could be some subsequent or secondary problem. Like if you heat tobacco like this, you can definitely heat it, but as the time goes, it becomes dry. So the temperature goes up, water evaporates, and it becomes dry, and therefore electrically insulative. And then we can try to still think how to make this concept realistic if we apply another tool that has been presented before, is going to be presented, is called function-oriented search. we try to find an industry in which to make something non-conductive. Conductive is a matter of life and death. And fortunately, there was an approach found in making conductive plastics. So definitely, if you can, basically plastics can conduct any current, but if you want to make it conductive for a reason, then you can add some graphite and graphite powder. And fortunately, in this case, if you use graphite powder for electric car, it has a lot of good properties. First, it is cheap. Second, it is electrically conductive, of course, and third, it is kind of smellless. So it does not add anything to the smell of tobacco. So the idea was to use the direct heating through electrodes to heat tobacco, and if resistivity is not high enough or resistivity is not controllable enough, so by the end of the cycle is becoming dry, then we add graphite in order to control the resistivity. That was the story when we went through application of function modeling and trimming for real project, where it was used in order to generate ideas, to ideate how we can circumvent a patent of competitors.